Alright guys, now we're going to be moving on to section 7-3, using multiplication properties of exponent. Please hit pause and do the 5 different warm-up questions. Now that you've hit pause, this comes out to be 2 cubed, which we know equals 8. Y times y times y times y times y is just y to the 5th power. 1 over x times x, or 1 is 1 over x squared. Without using an exponent, if you would have expanded this, we would have b times b times b. We always want to refer to this as cubed. C to the negative 4th, remember you can't have negative exponents. I would have circled this so then it was 1 over c to the positive 4th, which is 1 over c times c times c times c. Okay, now we are going to be using some multiplication. If you look at the next question, it says use repeated multiplication to solve the following problem. So what I mean by that is let's expand both of these powers. So we have 2 times 2 for the first one, for 2 squared, times 2 cubed is 2 times 2 times 2. Well now, if I were to go and write this as one big power, we have 1, 2, 3, 4, 5, so it's 2 to the 5th power. I want you to hit pause and notice if you can see anything that you could do to get from my beginning to my end and skipping that middle part. You're absolutely right. I bet you were guessing, well, 2 plus 3 is 5. In my glasses, what do we notice? Notice that you have here the same base. Big thing, both of those were a base of 2. You could not do that if you did not have that same base of 2. So when you multiply, what rule do you use? Well, you're going to add your exponents. So your product of powers property, so what that means is product means multiplication, is when I multiply like bases, I add my exponents. So for example, x to the 4th, base of x, times x to the 5th equals 4 plus 5, x to the 9th. We're just going to do a couple of examples together. Here, same base of x, x to the negative 3 plus 5, add our exponents together. Negative 3 plus 5 is just simply x squared. Now you can use your commutative property to rearrange so that like bases are next to each other. If they don't have a like base, you can't multiply them. So I'm just going to rewrite this as a to the 5th times a cubed times b to the 6th. I can only add my like bases. My b to the 6th, it's something altogether different, so I can't multiply that together. So we have a to the 5 plus 3 times b to the 6th equals a to the 8th, b to the 6th. Again, we're done now because they do not have like bases. For the number 3, we already have, we have 1, 2, 3 like bases. So let's go ahead and add them together. We have c to the negative 4th plus negative 3 plus 5. Negative 4 plus negative 3 is negative 7. Negative 7 plus 5 is c to the negative 2. But stop! What do you need to do? You're not simplified completely. You cannot leave negative exponents. No negative exponents. So we simply have to take this and write it as 1 over c to the positive square. You always have to simplify it completely. For the next one, go ahead, flip your page, and we're going to use repeated multiplication now to solve this. So inside your parentheses first, we have inside your parentheses 2 times 2 times 2 cubed, or, squared. So we have to write this 2 times, so it's 2 times 2 times 2 times 2 times 2 times 2. Well, let's put it all together. 1, 2, 3, 4, 5, 6. 2 to the 6th power. Do you notice anything? Do you notice anything? Well, here I think it looks like 2 cubed squared. This right here looks like a multiplication. 3 times 2 equals 6. So it equals 2 to the 6th power. So when you have a power raised to another power, what happens when you raise a power to another power? Well, you have the power of power property. It's getting very, very strong. When raising a power to another power, you multiply their exponents. And again, I think that it literally looks like multiplication. So 3 times 4 equals x to the 12th. Let's do a couple of examples. We have a power raised to a power. 3 times 5 equals x to the 15th. And again, if we're ever going too fast, you can always stop. Multiply here, a to the negative 2 times 3 is a to the negative 6. But stop! What do you need? No negative exponents. So you have to simplify it further. 1 over a to the positive 6th power. Well, now we have a product and power of powers. Let's do our power of powers first. And we're going to get b to the 2 times 3 is 6 times b to the 3 times, negative 3 times 4 is negative 12. Now, since it's a product, remember product, add exponents. So you're going to have b to the 6 plus negative 12, which equals b to the negative 6. Again, no negative exponents, equals 1 over b to the positive 6th power. Oh, we're getting really fancy now. Now, we're going to use repeated multiplication again to solve this problem. KR cubed. Well, we know that KR is written 3 times. So it's KR times KR times KR. Let's use our commutative property to put all our k's together. K times K times K times R times R times R. So put it together, you get K cubed times R cubed. Can you think of a way that we could have gone from here to here? In our classes, what does it look like? It looks like, I bet you thought of it, distribution. What operation do we use when we use distribution? It's always multiplication. If we would look at this 3, it's literally being distributed to both of these. K, R cubed, both of the K and the R, they really have an exponent of 1. 3 times 1 is 3. R times 1 is 1 times 3 is 3. So now we have our last rule. It's the power of product O powers. When a product of terms is raised to that power, each individual one is raised to that power. Again, it looks like distribution in there. Please cross out the example that you had and put this in here. Okay, now we're going to go ahead and do some more examples. Again, if you need to hit pause and go back, please hit pause and go back. So here we have 2 things multiplied in front of here. 2 is really raised to the first power. X is really raised to the first power. So we need to distribute our cube in there. So 1 times 3, because remember distribution you're multiplying, is 2 cubed times x cubed. Now we need to expand our 2 cubed. It becomes 8 times x cubed. Number 8, same thing. We have 2 powers in here, a cubed, b squared. We need to multiply our 4th power in there, and we get a to the 3 times 4 is 12, times b to the 2 times 4 is 8. Now let's move on to number 9. There's a ton in here, but that's okay. We have a product. We have powers. Let's just take it one step at a time. First, do you think we should multiply or do our exponent? Oh, exponents always come first. So let's distribute our 2 in here. We get c to the negative 4 times 2 is negative 8 times d to the negative 3 times 2 is negative 6. All of this is times distribute in our negative 2 here. C to the 0 times negative 2 is just 0 times d to the 5 times negative 2 is negative 10. Now let's rearrange again. Let's use that commutative property and have c to the negative 8 times c to the 0 times d to the negative 6, d to the negative 10. All we did here was rearrange. Now since it's a product, you just add. So we have c to the negative 8 plus 0 times d to the negative 6 plus negative 10. Once we add those up, put some equal signs in here that all these equal, we get c to the negative 8 times d to the negative 16. Both have negative exponents, can't have that, so we have 1 over c to the 8 times 1 over d to this positive 16. Multiply 1 times 1 is just 1 over c to the 8, d to the 16 is our final answer. Whew, that one was pretty intense. Number 10, let's go on to number 10 here. Number 10 is negative on the outside, 2x to the 5th, all cubed. This, remember, is really negative 1 times all of this. 2 has an exponent of 1, so let's distribute our 3 in. So this is really negative 1 times, in parentheses, 2 to the 3 times 1 is 3. X to the 3 times 5 is 15. Let's keep going. 2 cubed, do inside the parentheses first, is negative 1 times 2 cubed is 8. X to the 15. Now we can multiply our negative 1 and get negative 8x to the 15. You guys are doing a great job. The next couple of questions are pretty awesome. You're finding a missing exponent. So let's think about this. We have powers. We have g to the something, in parentheses, raised to the 6 equals 24. Oh, well, you know that this is a power raised to a power, so my box times 6 has to equal 24, because this is multiplication in there. Well, if you divide both sides by 6, you know that your box, your missing exponent, 24 divided by 6, has to be 4. Well, in here, let's think about what would have to be here. Oh, when you have product, you would have to add them. What plus 12 has to equal, and change your base here to an S, has to equal 15. Well, if you subtract 12 from both sides, you get that your box, your missing exponent, would have to equal 3. And the last one, you can't see your box, but it's out here. When you look at what it has to equal, let's think. Oh, this is a numerator, this is a denominator, what does that mean? Well, all that really means is this is b to the negative 4th and f to the negative 14th. So you know that you're going to have to be multiplying. So 2 times something has to equal negative 4. In the same way, 7 times something has to equal negative 14. If you divide both sides by 2, your box equals negative 2. Your missing exponent is negative 2. Let's see if it works over here. Your box also equals negative 2. So your missing exponent is negative 2. Right below there, I have a couple of simplifying rules. Make sure that you read through this and you have to have all these things when you're simplifying. The last thing that we're going to do is get some geometry involved. Get ready for next year. If the volume of a cube can be found by using this formula, the volume equals s cubed, where s represents the length of each side of the cube. Find the volume of the cube if each side is 4a squared b to the 4th. So you know here that s equals 4a squared b to the 4th. And the volume equals side cubed. Oh, so all you need to do is substitute this in. But remember, parentheses matter. So the volume equals, in parentheses, 4a squared b to the 4th all cubed. Distribute your cubed in, and you get your volume is 4 cubed. A to the 2 times 3 is 6. B to the 4 times 3 is 12. Last but not least, 4 cubed is 64. A to the 6, B to the 12 units cubed. Please try your own questions on your own now.